everyone. Good morning, good afternoon, good evening, wherever you are. And here you are joining us at OWASP AppSec Days Virtual 2024. The next session is all about policy driven vetting of open source components. And the speaker, Abhisek Datta, has been in the community for a very, very long time and has contributed a lot when we talk about open source. So let's bring him on stage and join him in this wonderful talk. Hi, Abhishek. The stage is all yours.
Awesome. Thanks, Vandana. Hey everyone, glad to be here, virtually speaking at OWASP AppSec Days India. Uh, I think the intro has already been done. So just to quickly set the context, I'm going to talk about a tool I created called VET, which allows policy-driven vetting of open source components, right? So we will see how VET can be leveraged in order to help security engineering and platform engineering teams build security guardrails against risky open source components. I wanted to give a quick intro, but that has already been done. But quickly also to talk about myself, my name is Abhisek Datta. I am the founder of SafeDev, a company that works in open source software supply chain security space. And I have been maintaining that for a while with support from the community. And this is the tool that I will talk about today. Okay, before we go into the detail, I want to start with a question. Maybe a bit rhetorical question. Who uses free and open source software? I think probably everyone, right? Like if you're thinking about it, mostly you are using free and open source software directly or indirectly. So Linux Foundation says that any modern software solution built today constitutes 70 to 90% of it coming from the open sources. So it means all the modern software ecosystem is heavily dependent on open source software, like say libraries, container images, software like say PostgreSQL. We have different distributions of Linux, and we also have so many other things like browsers, this and that. No matter what operating system we use, no matter what mobile phone we use, we are heavily using open source components. Although for this particular talk, we will look at it more from the perspective of software development. Assume that we are responsible for the security of a product. And just like every other software product, our product also heavily uses open source software component, third party open source components, right? So should we be worried about it? Do we need to mitigate some risks? That's what the agenda of this particular talk. We all know that open source or free and open source is really free, but is there a cost to it? Is there a hidden cost? I would argue yes, there is an inherited cost for open source. Just like there is a cost of maintenance for every single line of code developed in-house, there is also a cost associated with consuming or inheriting code from the open sources. Among them, from a security perspective, the top three cost or potential risks that I would say is really related to vulnerability, malware, as well as to a bit about maintenance. Although maintenance may seem not very security related, but we will see that it's very important from a security perspective as well. So I think many of you are already familiar with vulnerability related risks because, I mean, whenever I talk to someone and ask them, do you have something related to, vet open source libraries or open source components? Everyone tells me, yes, we have software composition analysis tools. They look at vulnerabilities and they tell us which vulnerabilities, we should fix by upgrading to what version. I think SCA tools has been there for a while, and it helps in learning about vulnerabilities in open source libraries. But as we will see that open source risks now today is actually larger than just vulnerabilities. So there are other risks as well, many of which needs to be proactively defended against, right? But before we go there, let's look at some examples that why should we care about vulnerability or malware or any of these risks coming from open sources. So let's look at the example of Zoho Manage Engine. So there was a vulnerability in Zoho Manage Engine. I think CVSS 9 vulnerability. It was rated as critical because it could be exploited to bypass authentication and gain remote code execution in Zoho Manage Engine. On analysis, I think the official advisory pointed out that the root cause of the issue was because of a vulnerability in the XML library, which Zoho Manage Engine was using. Because of a vulnerability which they did not update on time, uh, it was possible to, for attackers to bypass the SAML authentication and gain unauthorized access, and then leverage the features of the application to gain remote code execution. So this was one of the critical issues, and also a good case study on why you should treat vulnerabilities in third-party dependencies seriously, because that they affect your application, right? And if you're shipping your application commercially to your customers will not care that the vulnerability is caused by a third party open source library. Your application is vulnerable. You're responsible for it, right? Now, it's not just vulnerabilities. There are also inherited risks in open source due to malicious dependencies. This has been, a kind of emerging risk, but over the last couple of years, the number of malicious libraries has significantly increased. Most of us know about the XZ incident, where one of the popular compression library, which is indirectly used by really, really critical services on the internet, was backdoored, and a new version was shipped with backdoor. Not because the maintainer was compromised or infrastructure was compromised, but because the maintainer itself was malicious, right? So malicious open source libraries or components, or a newer version of a library, a trusted library, a reliable library, bringing in malicious code is of great concern today. One of the examples was, I think, apt example is ConnectKit, which is a popular NPM package used in cryptocurrency wallets and all of that. A newer version of ConnectKit was, used to deliver malware to various crypto wallets, which resulted in loss of, I think, almost $600,000. The attackers managed to compromise, and gain access to make a release of this particular NPM package, and through that they released a newer version which had some malicious code in it. So it's not just about the financial loss for this particular incident, but it's also about the loss of trust in general, which is caused when a popular product, especially enterprise product, shipped to a customer contains malware. Not because the team wanted to ship malware, but because by mistake they inherited something from third parties which had, say, malicious code. So these are some of the reasons why we should really take open source security more seriously now than ever before. Now we know that we have so far talked about some of the problems of open source software. Does it mean we can replace open source software? It's just not possible. Open source software is too important for the entire software development ecosystem. I recently came across, I think, HBR report that says that open source is now a critical part of the global economy, and if you want to, you know, build an entire software in-house, it would cost you at least 3.3 to 4 times more than what it would cost you when you are building by leveraging open source libraries and other components. So it's just not feasible for you to replace open source. But we also need to take care of the problems or the security risks that as a software development team we inherit from open source, right? So we have to figure out a way to establish or trust open source components before we use it in our software projects, so that we can ensure the software, that the final software artifact that we are shipping to our customer has a certain level of trust. Imagine this. Say, for example, you are you have a matured SDLC. You have proper code review practices in place. You have SAST, DAST, secret scanning, and bunch of security tooling in your own DevOps pipeline to ensure that whatever code your team is producing has a certain level of trust in terms of security. You can say that most common security vulnerabilities will not be there in the code produced by your team, because you have established a fairly secure DevSecOps pipeline or SDLC, right? Which is great. You can ensure that for your own code because you have it in your own control. But how can you ensure that for the code that you are inheriting from open sources? Sure, you can say that I am only using libraries which are popular. I'm only using libraries which are actively maintained. I'm only using libraries which do not have vulnerabilities. But if you really look at it, you will see it's not just the libraries that you are choosing. It's not just the components that you are choosing. Those libraries and those components in turn depends on a lot of other libraries, which in turn depends on a lot other libraries called transitive dependencies. So even if you add, say, 4 or 5, very popular and trusted libraries in your application as dependencies, you would most likely inheriting about 100 plus libraries. For I think NPM ecosystem, it will be what, 200 plus. Yeah, so your dependency graph is not just the libraries that you add, but includes all the transitive dependencies as well. So securing that entire inherited code base is important for you to be able to ensure that what you are shipping to your customer has a certain level of trust and security. So this is the problem. This is the problem statement on which VET was built. So when I started building VET as a free and open source project, by the way, VET is under Apache ASL2 license. It's free and open source. Anyone can start using it. Anyone can fork it, make their own changes. But I would love if you contribute back your changes to the repository. It will help mature the project. So that was really the motivation for building VET. How can we ensure that we have the necessary guardrails or necessary vetting process in place so that any code that we are inheriting from the open sources have reasonable trust to ensure that the overall security standard or the quality standard of our own software does not go down, right? So that was the goal for building VET. Now, VET is a tool built in Go. It has it's really a policy engine. We'll see, and I'll talk about the policy engine bit. Right? It is primarily built for security engineers and software developers because we probably did some trade-off in terms of ease of use to flexibility of use side of things. Right? So you can cover a whole lot of different use cases using VET, and it is also very easy to integrate VET with your own CI/CD or other vulnerability management tooling that you may be using. I'll probably just switch to my terminal and have a quick look at VET. Right, you can just install VET from its official GitHub repository, github.com/vet. There are a bunch of installation mediums that we support. The easiest way is that if you're on Mac OS or Linux, you can probably use Homebrew to tap into SafeDev's view tab and then install wet from there. Alternatively, you can build from source if you are gopher. I think I'm using the correct terminology, right? If you're a gopher, you would if you prefer to build from source, please go ahead, build from source. It's very easy. You can also use the officially built container hosted in GitHub container registry. It's pre-built for 64-bit Linux as well as macOS platforms. So you can just get started with that, right? So let's see how wet looks like. By default, if you just run wet scan, it will discover the open source packages in the current directory. It will not just scan for jars or packages, but it will look for manifests. It will also look into the code, and it will try to discover the the open source packages which is used in this particular software project, and it will find and report the top vulnerabilities in them, right? So it's as easy as that. It also supports some interesting integration. Like many people tells me that I want to be able to assess the vulnerability in a GitHub repository before I use a library or an artifact produced from that repository. So we built a easy integration with GitHub. You don't need to clone the repository. You can directly scan a GitHub repository using vet. Just pass the GitHub and the GitHub repository URL. You can also scan private repositories. All you need to do is just give the GitHub token available, and vet should be able to scan private repositories on GitHub as well. Even better, if you have the token available, you can actually give the entire GitHub org. So if you have a GitHub org with a bunch of repositories, you can the scan the entire org. It will take a while, but it has the capability to do that. I'll show you how. Instead of GitHub, you just do GitHub org and you do something like say safety, right? So it will start enumerating the repositories available in this GitHub organization and start scanning them. Yeah. If you do not provide the GitHub token, by default, it will scan public repositories. If you provide the GitHub token, it will also look into the private repositories as well. So it is a good way of quickly having the necessary data in place for your entire GitHub organization, so that you can find interesting things that we will see shortly. Now, before we look into the other use cases, let me give a brief overview of how VET works. VET, in its entirety, is really a policy engine. VET has this Google's Common Expressions Language interpreter embedded inside it. I think the CEL is a very popular expressions language now. Even I think Kubernetes adopted CEL. So VET is really a policy engine leveraging this common expressions language. VET also have the ability to discover third-party open source libraries and other components by parsing package manifests like say package.json, pom.xml, by this gradle.log file, as well as going through the code. So VET has a code analysis capability as well. This is something we are actively working on at sort of preliminary level, but yeah, VET also have code analysis capability. So VET first discovers all the open source components that it can by going through your code base. Then it uses something called insights. We internally call it insights to gather security metadata about all the discovered open source components. When I say security metadata, I mean stuff like vulnerabilities affecting that particular version of the library, the OpenSSF scorecard, the license information, GitHub metadata like when was the last release, how many contributors are there, how many stars are there in the particular GitHub project that released that particular package artifact, right? So VET enriches the discovered open source libraries with security metadata, and then just allows its users to define their own policies to determine based on the security metadata whether it is safe or unsafe. And the final result of this policy decision is available to you as a prioritized list of issues or a list of packages which failed the policy checks, or as JSON report, or a SARIF report, or a CSV report, right? That's it. Wet is built really to integrate with your developer or platform or DevOps workflows. So now you may ask that why make this such policy driven? Because in my past organizations, or even when I wanted to use vet to vet my own open source project, one of the things that I felt is that the definition of risky open source is not a standard one. What is risky for me may not be true for someone working in a larger organization, or what is risky for, say, the security team in a very large enterprise is not same as, say, a platform engineer working in a startup. We would want all of them to use vet, and so that they can codify their opinion of risk. We adopted this policy engine. All you need to do is write down your definition of risk using a very simple policy language, and that's it. You have vet which can vet your open source exposure, open source components as per your opinion, right? So that is how vet works, and that is the direction vet will go. Vet's policies are very, very simple. You do something like once.critical.size greater than 0. We kind of internally model this both as a policy language, as a filter, and as well as a filtering language. Now, what do I mean by filtering? So one of the things, as I said, vet is primarily built for security engineers and platform engineers who want to discover what they need. One of the things that we can do in vet is dump the data using something like using this command line. I'll skip this graph part. This JSON dump dir. So whenever you are using vet to scan anything, be it a GitHub repository or something else, you can scan or you can dump all the data identified by vet in a particular directory. Now, how does it help? It allows us to slice and dice the result from the command line itself. We can do something like this: vet query from that dump directory, and instead of report, we will do something like this: filter. See, it's the same thing. What I'm doing, once.critical.size greater than 0. Okay, I tried something else here. Let's do the same thing. Once.critical.size greater than 0. Right? Oops, I think there is an issue here. Once.critical. Yeah, once.critical. Okay, let's use the other one. Yeah, this one worked. I probably need to fix the slide or look at the other one. Once.critical.size. Okay, that should also work ideally. Anyway, so what I'm doing here is really executing a query using the CEL common expressions to identify only the critical vulnerabilities, right? Say we can also look at other vulnerabilities, right? You can do something like vulns.critical.exist be true, or say high.exist be true, right? In this way, you can discover or you can set exactly what you're looking for. You can also filter by OpenSSF scorecard. You can do something like scorecard.scores.maintained equal to 0, right? And it will tell you all the packages which has an OpenSSF score of maintenance to be 0, right? So we support all the attributes which are published by the OpenSSF scorecard. So this is why the filter is built using a policy language. You can find whatever you're looking for. You don't have to be restricted by the CLI capability or the UI. Now, we do have a bunch of videos to get started with wet, but I think the best place to get started if you are interested in evaluating wet is the official documentation. Get started. We have good documentation. We have a decent community. You can come to our Discord as well as raise all these things. Wet also have native CI/CD integration, especially for GitHub Action. We have wet action using which you can quickly integrate wet as part of CI/CD only. So let's see an example. I'll look at wet. So we heavily, dog food wet. That means we use wet for wet's own development. But yeah, sometimes we have to accept, not so maintained dependencies sometimes. So let's see, for example, add support for viewing cloud query. Let's see somewhere where we have, let's look at this dependency upgrades. So I recently did a dependency upgrade. I upgraded, two libraries. And if you see here, the vet's GitHub action actually identified only the changed dependencies and vetted the dependencies as per my defined policies. Now, when I say policy, let's see what policies looks like, right? Policies in vet is exactly same as those CEL queries that we looked at. The same thing defined in a YAML document. So that means you can write the queries as per your own opinion to identify your definition of risk, right? And you can put all these queries together in a YAML file, and that becomes vet's policies. And vet will automatically vet changes in a pull request, changes in open source libraries in a pull request using the policy that you have defined. Right? Say, for example, let's look at this policy. This is an interesting policy. So this basically looks for open source packages in my code base where the GitHub project is known and the number of stars is less than 10. While it may not always be a risk, but sometimes from experience, it seems like it's not a good idea to consume open source libraries from really unmaintained or projects which do not really have a community. Luckily, in this case, we don't have any library where the number of stars is less than 10. If I search for less than 50, I do get some. But again, the idea of policies is to codify your opinion. So I generally check for how popular is the project which is producing a library artifact, at least for now, till we have some really cool features of automatically vetting a project as well as looking for malware. But for now, we just look at the stars. Right? So using this, that just fits in right into the CI/CD. Okay, so far we have seen about Vet's ability to discover risk. Before we go into the fixing side of things, which is one of the most important aspect of any kind of vulnerability management program, I want to quickly demonstrate the filter capability. Right. So the same policy that I showed you on the GitHub screen, it's the same thing is available here. You can run any command, say for example, which scan this is, and pass a filter suite, samples filter suite this, and you can do something like filter fail. It tells vet to fail if any of these filters are matched. Any of this. So this basically helps in setting up guardrails. You can define what is not desired, convert them into CEL queries, and use this to establish a guardrail in your CI/CD. If you are using GitHub Action, you probably don't need to do all of this. You can just use Vet's GitHub Action. But if you are using your own CI, you can codify your policy in a YAML file and then leverage. Oh, oops, I made a mistake. Instead of scanning a particular repository, I tried scanning the entire organization. It will take a long time. So let's just do client Java for a particular project. They should complete fast. Yeah, waiting, almost done. Let's see. Just want to show you the filtering bit. If you see here, the filters matched. It looks a bit jumbled up because I had to zoom in this my terminal for this particular talk. But you can export this filter matches into CSV or JSON and integrate with your own tool. Yeah. So that's about the wet's risk identification part. But when I use wet myself to really safeguard against risky dependencies, it's not always new dependencies that I want to block. If I scan existing project, a fairly large project or a legacy project, a legacy software project with vet will probably find a lot of issues, and it's not easy to fix vulnerabilities in code, especially when you do not have control over the code, especially if the code is inherited from third-party dependencies, right? So fixing is hard. Fixing is always hard. So we do have some focus on fixing, and one of the area that we are working on is the reachability analysis. I think there has been a lot of buzzword around reachability analysis. If you want to know about reachability analysis, do ping me, and I'll be very honest with you that it's very hard problem. A lot of people seems to offer reachability, but you should definitely check because the in order to perform reachability analysis, which is basically the process of identifying if your application is actually vulnerable to a particular vulnerability in a library, because that's what you care. You don't care if there is a critical vulnerability in a library that you use, but your application just don't use the vulnerable code, because it's not the entire library that is vulnerable. It's some code block in a particular function which is vulnerable, or maybe one or more function that is vulnerable. You will care as a consumer of that library only if your application is vulnerable, right? So that is the idea of vulnerability prioritization using reachability analysis. In order to do that, you need to build a call graph. Building a call graph for a single source file is probably easy. We have done that long time back. But building a call graph across an entire application, all its source files, all the source files of its dependencies, and all the source files of its transitive dependencies is a hard problem, because you need to store a lot of information. Also, in dynamically typed languages like say Python or JavaScript, it is incredibly hard to correctly resolve the target function that you have been called. You will not always like call a function by its name. You will probably have a instantiate a class, you call some method, that method produces say a function, that function is assigned to a variable and you call that variable. A lot of dynamic things, runtime stuff can be done, which makes accurate call graph building is hard, right? So this is something we have been working on for a while. If you want to talk about the challenges or brainstorm on solution, happy to do it. Vet builds something called dependency graph. That means Vet tries to reconstruct the relationship between dependencies after it discovers them in your code base. Now, this is easy for cases like say package.log.json, which has that necessary information. But this is not very easy for cases like where you're looking at a pom.xml or a gradle.log file, which just consists of flat list of resolved dependency list without relationship. Now, why do we care about dependency graph? Why do we need that? During the early days of when VET used to find a vulnerability in a transitive dependency, we used to get feedback from our users that I have not added this dependency. I don't know how VET found it. So VET found it because VET discovered it as a transitive dependency. Now, telling the user to fix a transitive dependency is hard because by default, most developers do not see them, do not have much control over them. So we built this dependency graph reconstruction so that VET can trace back a transitive dependency into one of its top level dependency which introduced it, right? So this was really a technology for building something like this. So what is this? This is basically grouping libraries that should be updated because of vulnerabilities or other risks by its top level dependency. Say you are scanning a legacy application and just found hundreds of vulnerabilities. So how do you begin? Maybe reachability and other prioritization technique can help you. One of the things that we have seen is incredibly useful is if you can find the top level dependencies which led to introducing libraries and other dependencies which has a lot of vulnerabilities. If you update those top level dependencies, there is a high likelihood that the transitive dependencies will also be updated, thus resolving a large number of vulnerabilities and showing you a sharp decrease in your vulnerability management dashboard. Which is why we invested in building this feature of dependency graph reconstruction and this group by direct dependencies. Do check this out. Check this feature out. You can tell VET to report the findings grouped by direct dependencies. That should help in remediation efforts. So that's about it. I think again I want to reiterate that VET is a free and open source project. Anyone can contribute. In fact, there are many people who have already contributed to VET, and I think the direction of VET has organically evolved based on user feedback. Initially, we were looking at only at finding vulnerable or risky libraries with policy. Then we later realized that while that is important, fixing is also very important, right? What do you do? What do you do when important feature needs to be shipped and you add a popular library, which is a must-have requirement for the feature, and that library in turn introduces a whole bunch of library which violates your policy, which violates your definition of open source use, right? So what do you do then? Do you accept that because you have to ship the feature, or you block that, in which case you are basically causing a blocker for the business, right? So these are real practical situation that we face all the time. So because of these experiences, VET's focus is kind of going to more towards the fixing side of things. So you will see that many of our features are kind of towards helping developers and security engineers in remediation or fixing issues.
Thank you so much, Abhishek. That was a wonderful session about wet and open source components. And there's so much to learn from you about this topic. And I'm sure a lot of people from the audience would reach out to you to know more about wet and to learn about how we can implement it in the organizations. Thank you, everyone, for joining today for this session, and stay tuned for the upcoming session. Thank you.